afternoon to respected ma'am and all my dear mates. Today I am called here by our beloved Guru ma'am to give a lecture on the following of electric flux and electric potential energy. So let me start. My name is Priyabrata Sahu and I belong to second semester of Dugapu Government College for BSc Physics Honors. So before moving on to my original topic of electric flux and electric potential, I would like to introduce the two fundamentals of the topic, that are the electric field and the electric field lines. So introduction to electric field, as we all know, electric field is a region around a given charge in which we can exert force on attraction or repulsion on other charge. The following are the mathematical expression for the topic electric field. As we already know, the force is directly proportional to the charges Q1 and Q2 and is inversely proportional to the square of the distance between them. And combined, we can say that the force is directly proportional to Q1 and Q2 by R square. If you replace the proportional sign, you can replace it by a constant known as K, and the value of K for the SI unit will be 1 by 4 pi epsilon naught. So in vector form also we can write that form of force equals 1 by 4 pi epsilon naught Q1 by Q2 by R square, and the direction will be the direction of R dash. Now coming to the next topic, that is the electric field lines. Electric field lines originate from the positive and terminate at the negative charge. Tangent at any point on electric field lines denote the direction of the electric field lines at that point. Two electric field lines never intersect each other because at the point of interaction there will be two directions of electric field lines. It is not possible. Density of electric field lines represents the intensity of electric field. Number of field lines is proportional to the magnitude of charge. If field lines are parallel to each other, then they represent uniform electric field. I will like to give an example by the following diagram. If this was an electric line, then here there is intersection between them. Then if we draw two tangents from here, it gives us two different directions, which is not possible. And coming to the next point, that is the magnitude, it depends on the magnitude of the number of field lines. Then we can see that one charge there is Q and the next charge is 2Q. If there are two field lines, here we will get 4 field lines here. So this is what the last point of my slide means. And density of the electric field is nothing other than the number of electric field lines passing through a given units of the same. If there are n lines, then the density of the field line will be n divided by the total surface area given. Now I will come to the electric field line diagram for isolated charge and paired charge. First I will come to the isolated positive charge where the electric field lines are originated from, and then I will come to the isolated negative charge where the electric field lines come and meet finally. And then comes the two like charges and two unlike charges electric field lines. The first one is between two unlike charges, and the second one is between two like charges. Here we can see that the electric field line originates from this positive charge and terminates at the negative. And there, both are like charge and both are positive, there is a definition of the electric field line from each other. So now let me come to the original topic, that is the electric flux. As you all know, the main formula for the electric flux is E, electric field and the area vector at dA cos theta, and theta is the angle between them. Introduction to cos law. As you all know that the base for studying electric flux we need to understand at least the basics of the Gauss law. And here it is. Flux of any vector field A passing through surface S is defined as by the following: phi equals to integration surface integration of A vector into n cap dot dx. The n cap is the integral amount vector to the surface and ds is the area. Flux of a vector A passing through a closed surface. Particular what forces are given in the diagram inside. You can write as flux of closed surface integration of A vector dot n cap dx or A vector dot ds. Now coming to the electric flux. The flux into electric field is called electric flux. And electric flux passing to any surface S is equal to phi equals to double integration E dot n cap dx. Electric flux passing to any closed surface can be represented as phi equals to closed surface integration electric field dot n cap dot dx. And here is the following diagram for a spherical body, where you can see that the electric field lines are originated from the positive charge, and the dA is the area vector that is perpendicular to the surface. Electric flux is nothing other than defined as the number of field lines passing through any And here you can clearly see that the electric field lines are passing through the given surface, and K is a perpendicular vector to the area surface, to the given area, and T is the electric field. So one more slide on that. T is the electric field, A is the surface area. Electric flux depends on the strength of the electric field E, the size of the surface A, and the angle between E and T, respectively. Now coming to one application of the Gaussian rule, let us consider a chart. Q is placed inside a sphere of radius r. Then what will be electric flux passing through surface of sphere S due to charge Q? Since I equals to cos of integration of E dot n cap dot ds, also we already know the value of electric field is 1 by 4 pi epsilon naught into K by r square. Then we can write the following of the phi, that was phi equals to cos of integration of E dot n cap dot ds. Here we can write that as phi equals to surface integration of 1 by 4 pi epsilon naught into Q by r square dot r cap dot ds. Now by using the spherical coordinate system, we can get the value of ds from here, and you can see that ds equals to dl theta and dl phi, and therefore here we get the value of ds equals to r square sin theta d theta d phi, and then we can get the following, and finally we can keep to the phi equals to Q by epsilon naught. We know according to the main formula of the Gaussian law, that is the chart enclosed by epsilon naught. And the limit for the integration of the following calculation is given there beside. Limit for first integration ranges from 0 to pi for theta, and limit for second integration ranges from 0 to 2 pi for phi. This is in Gaussian, and this is the main formula as already know. The charge enclosed divided by epsilon naught for the Gaussian law. Now Gaussian theorem. According to Gaussian theorem, electric flux passing through any closed surface, Gaussian surface is equal to 1 by epsilon naught of the total charge enclosed by surface. Phi equals to Q enclosed by epsilon naught. Some important points about Gaussian theorem. Gaussian surface must be closed, and its shape can be anything, but we choose those surfaces which is easier and simplified, so that our calculation is easier. Charges outside the Gaussian surface have no contribution in flux passing through given surface. For example, if I say that here is a body, and here is Q1, Q2, and here is Q3. Then for this one, the flux will be Q1 plus Q2 by epsilon naught. The Q3 one impacted in this following because it is lying outside the boundary of this falling in body. Gauss law is valid only when Coulomb's law obeys reverse coil law. Gauss law is equivalent to Coulomb's law. Now coming to my next topic, that is the potential energy. What is electric potential energy? Is the main topic. The potential energy of a charged particle in an electric field relation to electric potential measured in joules. As you already know, the value of electric potential energy is calculated in joules. So now my slides for electric potential energy, the force that shapes the cosmos. As you can already see, the chart line of traveling from the positive plus the negative, from high potential to the low potential energy area. What is electric potential energy? Electric potential energy is the energy developed due to the charge's position in an electric field. Q equals to QV here, where V is the electric potential. Analogy, it's the stored energy in a spaceship just before warp job. Also, I would like to make you focus on the diagram given inside. That force, from force we can calculate field, and from field we can calculate force, and from potential energy we can calculate potential, and from potential we can find out the potential energy. All the four things are related to each other by the following methods. Now coming to electric potential difference, which is also a basic topic for electric potential energy. 2 points of different distance from a charge will have different electric potential. This is because electric potential increases the distance from a negative charge and decreases the distance from a positive charge. Therefore, there is an electric potential difference between the 2 points. Therefore, we can write delta V equals to VA minus VB, where VA is the final potential energy and VB is the initial potential energy, which is denoted here by VA and VA respectively. From here, we can find the potential difference due to a point charge value. Delta V equals Q by 4 pi epsilon naught, 1 by R final minus 1 by R initial. R final and R initial are the distances from the point charge to the point charge at 2 different points, and final and initial point. But Q is the magnitude of the point charge producing the potential. Epsilon naught is the permittivity of free space. R final is the final distance from charge Q. R initial is the initial distance from charge Q. There is the following the formula for the electric potential energy. U equals to V1 into 2 by R, and where K is the Coulomb's constant 8.99 into 10 to the power 5, and Q1 Q2 are the charge, and R is the distance between them. Concept is the work needed to assemble system of charges. This is the formula of the electric potential energy. Similar to electric potential, values of electric potential energy depend on the sign of Q1 and Q2. By definition, potential V equals to 0 at infinity. Therefore, epsilon naught equals to 0 at infinity. You know, unlike electric potential, the value of electric potential energy will always be positive. This is one more formula for the electric potential energy from the last page only, where we can see that delta E equals to Q into delta V, where delta V is the potential difference and Q is the charge. So we can get this following conclusion from the above the last topics. This is what the means equal to charge, small q equals to charge in moving electricity, R1 is initial, R2 is final. Thank you.